What is SFT versus RL, or instruction tuning versus LHF? So today, I want to break down these two fine-tuning methods in simple terms and walk you through two seminal AI research papers that demonstrated how they are used in training modern LLMs. For SFT, or supervised fine-tuning, what this fine-tuning method does is essentially showing the model exactly how you want it to behave in a domain or task of interest, and the model learns by copying these patterns. A seminal paper that applied SFT is called Fine-Tuned Language Model or Zero-Shot Learners by Google, released in 2022. In this work, researchers collected a dataset of questions and answer pairs across different NLP tasks. Each data point follows an instruction following template where a user asks a question or gives an instruction and a human writes an ideal response. After training, at the end, the researchers evaluated the resulting model called FLAN on unseen tasks. The paper showed that instruction-tuned models learned to have greater behaviors in instruction-based question answering and expanded its ability in unseen task types. Reinforcement learning, or RL, on the other hand, is used when the goal is not learning through imitation, but through outcome and preference. In the context of large language models, RL commonly shows up in the context of LHF, or reinforcement learning through human feedback. This idea was most notably introduced in the famous InstructGPT paper by OpenAI as the second training phase after SFT. Humans were asked to look at multiple answers generated by the model, rank them from best to worst, and based on these rankings, the LLM is then trained to maximize the good responses or the responses with the highest reward, essentially shifting towards outcomes that humans prefer. Over time, this helps the model to become more helpful and aligned with human intentions. So when do we use which method? Essentially, you want to use SFT when you want to further emphasize knowledge already present in the model, customizing its responses structure, format, or tone, or sometimes optimizing cost or latency. For RL, you want to use it for complex domain-specific tasks that require training for advanced reasoning, refining existing partial capabilities to foster new and emerging behaviors, and is most suitable for tasks with measurable feedback. Often, you will want to actually combine both approaches, first using SFT to teach the model a specific output format, and then using RL to refine the model toward better reasoning and alignment.